Okay, so today we will talk about recursion. Um, I'm gonna go through the syllabus of the workshop real quick, so you know a little bit about the structure, and then we'll go through two examples. And if you guys do, it's a big, large topic, so today we'll just scratch the surface of recursion, and if you guys will actually understand the logic of how it works, then I did a good job. Then it will be a good workshop. So, definition: recursion. Recursion is way to solve a problem by defining a function and that calls itself. So you apply the function and its own definition. Yeah. Yeah. So this function is called then a recursive function. And how it's different? The what? The light? Okay. So how it is different from normal function? I'm going to show you right now. It has two elements that distinguishes a recursive function from normal function. One element is called the recursive call, which makes the function call itself, and the second element is called the base case, which stops the function from calling itself. It's also called a terminating condition. Otherwise, if we don't add a base case, it will be not practical to use a recursive function because it will just continue calling itself with no reason. So I will show you now. I will create a function so you'll see how the syntax looks. That will explain it, to you which one's the base case, which one's the recursive case. So let's say we want to count from 10 to 1. We'll create a countdown function for the first example. It's pretty simple, but good enough to see how a recursive function works. So countdown, declare the function. Parameter will be the number that we want to count down from. I will call it n. Then I will add, this is the base case, so if n equals 0, then return. So we want to count down to 0. We can choose a different number, depends on when do you want the function to stop counting down. We want a console log. So we'll see the result, console log n. We'll call the function. With n minus 1. So we want to always count down one number less. So if we'll add like n minus 2, it will count down every second digit from the starting point, and it will stop at 0. So let's say 10. I'm going to count down from 10. So we have the function identifier countdown, parameters n. In the function body, we have the base case. So if n equals 0, then return. This is when our function will stop calling itself. And this here is the recursive case. So this is the element that makes the function keep calling itself and decreasing until it reaches our base case or the terminating condition. So let's run the function, and afterwards I'll try to use breakpoints so you will see how the function is executed. It's easier to understand. But count down. Oh, yeah, sorry guys. Oof. There we are. Sorry about that. And here we are. Let me clear the console one more time. So we have a countdown logged on the console from 10 to 1. So now let's see how the function is executed. I'll try to add some breakpoints here. I hope it will work. It won't. Don't think it will, but let's see. Of course, when I tried at home, it worked, and when I have to do the presentation, Google Chrome does not collaborate.
Try to add a breakpoint. Maybe line number 4 or 5 and see if it works.
5.3 will be good.
Yeah.
Number 1, no. And number 2, actually, no. Okay, but let's see. Let's use only these breakpoints, see if it will work. Okay, yes. So the function gets called initiated. Then no. Then we'll jump at line number 3. So if n equals n at this point is 10. So if n equals 0, then return. N is not 0, so we won't return. So we'll continue executing the function. So then goes line number 4. Then it will print 10. And we'll jump in line number 5, where the function gets called again, but this time as an argument we have n minus 1. So the recursive call will call the function again. Then it jumps at 3, line number 3, where we have if n is 0, return it's not 0. This time n is 9, and it will go so on until it would reach. So until it would reach n to be 0, and then the function will stop running. So it calls itself 10 times. Now we'll stop. Yeah. So this is actually how how a recursive function works, how it's executed. It's also, there are some pros and cons about recursive function. In some cases, you don't want, for some simple, not so complicated problems, you don't want the function to call itself so many times. You can solve the problem maybe differently using a loop or an iterator, but in some cases you will have to use a recursive function. For example, if you have if you want to create a list of data of the size, and the size is unknown to you, you don't know how big the list will be, then you will have to use a recursive function. Otherwise, you can break the problem down in multiple smaller functions. They use iterators or multiple nested loops. And let's go to example number 2, and I will show you one more way to use a recursive function. This time we will calculate a factorial of a number. So you can do this using a loop as well, but I want to demonstrate how how recursion works. So yeah, equal up. Sorry guys. Factorial equal x semantics. Then we have our base case. So if x is greater or equal to 0, and I will tell you why we select this base case. It's math actually. The factorial of 0 will be 1 and math through, and factorial of 1 is 1 as well. So we know that. So we'll set that as base case. And then if this is true, return. Else, x minus 1.
Does everybody know what the factorial of
I
a
will
number is?
explain now. The factorial of a number, so example, factorial of 5 would be 1 times 2 times 3 times 4 and times 5. So till 5. Factorial of 10 will be 1 times 2 till 10. So you multiply all the numbers from 0 to that number. That's a factorial. Or from the number backwards to 0. But the factorial of 0 is always 1. So
Can
we need to
anyone
keep
tell
that.
us what's the factorial of number 3, for instance?
Log factorial of let's do 5. So we declare a function, arrow function. We have x as a parameter this time. Base case, if x is greater or equal than 0 and x is smaller or equal than 1, then return. Else, now we have this is this time our recursive function, recursive call over here. So else return x times factorial of x minus 1. So let's console log, let's run the function. Let me clear the console. Not a number? Why do I have not a number now? I have a mistake.
What happened on the base case? What are you returning?
Base case?
Yes?
Oh yes, sorry. I'm looking at 3 screens and trying to make eye contact with you guys as well. Sorry about that. So yeah, return 1. Yeah, that will be our base case. So factorial of 5 will be 120. So let's see how this function is executed, because I think it's pretty interesting. Let's go to the console, add some breakpoints. Okay, good enough. Can we do one here? Yeah, nice. So I clicked on 1 and breakpoint was set at 2, but it's good for us. So let's run the function and see how it's executed. So the function, first line is being called. We recognize it as a function, arrow function, then jumps to line number 10. The function is being initiated or it's being called, then line number 3, the base case is executed. So if this is true, then return 1. X is 5 at this point, so if 5 is greater or equal than 0 and 5 is smaller or equal than 1, then return 1. That is not true. So else it's being executed where x is being returned multiplied with the function being called again, so with a recursive call. And this time as a parameter we have 5 minus 1. So you'll see when the function is being called now the second time, x is 4 because we took one from here over here, so x is 4. Then the function continues running, it's still not returning 1, jumps line number 7 again, and it goes so on till x is 1, and now the function will return 1, and the factorial of 5 is then 120. So we have here we have 1 times 2 times 3 times 4 times 5 is then 120. This is how it works. Let me show you guys some other examples. I have actually tried to explain the logic now using just like a simple picture. So for a practical case when we can use recursive function. So when our problem contains multiple sub-problems, so when you need to solve a bigger problem but it's composed of other smaller ones and smaller ones and smaller ones, that's a pretty good case actually to use a recursive function to solve that problem. So in this example, let's say we want to count how many so we have some boxes, we want to count how many circles, black circles, are in these boxes. So using a recursive function, the function will run and iterate through the first box and see how many circles are there. But in the first box we have other 2 boxes that are nested inside. So we say it will return 1, but I still need to run to because I have other categories underneath. So it will go and it will check the second line of boxes, but they also have other ones. So we'll keep the function will store all this data, and it will collect the data of all the sub boxes, and then they will add them up, and same will happen here, and the data will actually be saved and collected in a stack, and then it will return the function will return the result. So this function will be called how many times to get the result? 5, 6, 7, 8, 9 times to get the result of how many circles we have. So this will be a practical case when you can use a recursive function when you have to iterate through nested objects, or when you want to create a list that contains multiple subcategories. So in e-commerce example, if you have a shop and you have a list of items and you want to place them into categories which contain other subcategories and subcategories, then you can use a recursive function to do that. Yeah, so the storing of the data is called a stack. Recursive functions are limited because they go till they can easily turn in infinite loop. So if you don't have the base case, they can go turn into an infinite loop. So they're all limited. The browsers are limited to, I think, Google Chrome 16,000 calls. So afterwards, it will stop you. It will stop your function. Google Chrome will stop working as a security measure. And also your stack, depending on your memory that you have, your stack will be limited as well. So if you build multi-dimensional trees, and if the trees are too big, you might not you might have to um, create multiple um, recursive functions to solve the problem. So one function might not be enough. You might need to break the problem down in other smaller problems. So yeah, it's a very complex topic. So guys, I really recommend to study it, because it can be very practical to use recursive functions. You can always use them instead of loops. You can use them as iterators, but it's for you to decide. It depends of how the magnitude of the problem, if you really need to use a recursive function or not. So it's for your experience to decide. Do you guys know now how the logic behind recursive functions? Can you recognize one if you see it? If you see the recursive call, so if the function is in the syntax, if it's calling itself, then it's a recursive function. And then if you want to use it as, it's very important, these two elements are very important, because if you want to make the function be practical, you need a base case. Otherwise, if you don't have the base case, it will turn into an infinite loop. So it will keep calling itself with no condition to stop. And then what else can I tell you? Yeah, it can help you shorten your code. So if you have, again, a problem composed by other smaller problems, instead of writing nested loops, one loop nested in the other, second one, and so on, you can use recursive function to shorten the code. Even though, because calls itself so many times, I'm not sure if from a performance point of view it's better, but it will shorten your code. Any questions? Cool. So yeah, that's all I have, guys. If you still want to learn, which I recommend to get a deeper view of a deeper understanding of recursive functions, check Wikipedia, YouTube. There are many videos. It's a pretty interesting topic, and some employers I've seen, they do have some exercise, maybe not for junior developers, but they do have some exercises that they ask the developers to do it involving recursive functions. So yeah. Cool. Thank you very much.
Vivian.
Thanks a lot.